Okay, so we'll go back to another video. So here's a trigonometric integral we're dealing with from 0 to pi over 2 of cosine of 5x plus cosine of 4x divided by 1 minus 2 times cosine of 3x dx. So pretty much the premise of evaluating this trigonometric integral really is we're simplifying our integrand to make things a little bit easier. So it's more of those clever tricks that we want to utilize and fix up to make, evaluating things a little bit easier. So really, the whole point is just using a bunch of trig identities for one. The one we'll be using specifically is that we have cosine that we'll actually be using the exponential function that to help do that substitution. And there's also a little bit of some algebraic properties that we'll be using. Specifically, you'll know that eventually we'll be using polynomial long division to simplify things even smoother. And eventually, it does come down to a simple number. So with that out of the way now, let's actually just jump right into it. So as mentioned, we have cosine, so we'll use the exponential definition. So that says for cosine of x is equal to e to the power ix plus e to the negative ix divided by 2. So replace everything in here for our integrand. So that means cosine of 5x plus cosine of 4x, all this being divided by 1 subtract 2 cosine of 3x. Indeed, it's just going to be written as follows. So we have e to the power 5ix plus e to the negative 5ix, and add this with, divide by 2. So let me actually take things one step at a time first. Divide by 2, add this with e to the power 4ix plus e to the negative 4ix divided by 2. So that's just from the numerator. Everything under the denominator now is going to be 1 minus 2 times, and then we have cosine of 3x, so e to the power 3ix plus 3 to the negative 3ix, and then divided by 2. Luckily enough that we have the 2's that cancels, that'll make things a little bit easier, and I can factor out the 1/2 from the numerator over here, so that'll yield us 1/2, and then multiply with e to the power 5ix, add this with e to the negative 5ix, add this with e to the 4ix, add this with e to the negative 4ix, and then all this being divided by 1 minus e to the power 3ix, and then subtract e to the power negative 3ix. Looks like there's a bunch of things going on, but that's not nothing to be scared of, because we can actually suppose that we can do a substitution. We'll let, not a u substitution, but a different substitution. We'll let t equals e to the power ix. So now everything in this equation over here will be written in terms of t. So let me actually stick with the pink this time. So now yielding us so far is going to be 1/2 then times t to the power 5, add this with t to the power negative 5, add this with t to the power 4, add this with t to the power negative 4, all this being divided by 1 minus t to the power 3, and then minus t to the power negative 3. And now to make things a little bit easier for us, because after performing this next step, we're actually going to get into the long division with polynomials. Let's actually multiply a t to the power 5 to both the numerator and denominator. So now that will yield us 1/2, then times t to the power 10, add this with just 1, plus t to the power 9, and then add this with t. All this divided by t to the power 5, minus t to the power 8, and then minus t to the power square. So now here comes the polynomial long division. So what I'm going to do here is that we'll disregard the 1/2 for a bit, and then what I'm going to do is I'm going to rearrange our terms such that it starts with the leading degree, the highest degree, and it goes downwards. So now yielding us, from here, that I'm going to write long division of polynomials. And so what we'll have to do is we're going to actually do the following division of t to the power 10, add this with t to the power 9, then add this with t, then add this with 1. All this being divided by, so I'm going to actually put in the leading highest degree, so now this will be divided by negative t to the power 8. Add this with t to the power 5, and then subtract t to the power square. Okay, so now with that, let's actually get to the long division. So now I have our divisor, so negative t to the power 8, and then minus t to the power 5, or rather plus, then minus t squared, that's our divisor, and then everything is being divided by everything here. So what I'm going to actually do here is that because we have some terms that don't exist for like the other degrees, so for example, we don't have an 8th, we don't have a 7th, we don't have an 8th, but to make things a little bit easier on how we perform this log division, I'm actually going to write out a 0 times t to the whatever power that's not included in the numerator. So with this case, we have this t to the power 10, then plus t to the power 9, and then plus 0t8 plus 0t7 plus 0t6 plus 0t5 plus 0t4 plus 0t3 plus 0t square plus t, and then add this with 1. And so I know that's a lot to intake, but don't worry about that. So now all we have to do is now perform that long division. So let's say that now over here we can actually multiply negative t to the power square into our divisor. So that'll give us, now this is positive t to the 10, and then multiply here, this will be subtract t to the 7th power, and then now multiply the t squared, so that'll be a positive, so that means t to the power 4 over here. Then actually perform all that long division, well, we subtract, so that means that's gone, then that'll yield us with a positive t to the 7, and then up above over here, and we also have a t9 over here that's exists, so we have to bring that down as well. And then subtract here, so that means that'll give us a minus t to the power 4, and then now drag down the t and then the 1 down here. So now next, let's multiply another, so instead now we're going to multiply minus t to the negative, or rather t to the power 1. So doing so, that means will give us now a t to the power 9. Then over here, that'll give us subtract t to the 6. Now that'll yield us with minus t to the q power. Then we actually subtract everything from down below. So now all we have to do is now perform the subtraction over here. So this will just be canceled to 0. Over here, this is going to be t to the power 7th. And over here, this is going to be t to the power 6. Then right here, this will be a minus t to the power 4. Then back here, they'll yield us with a minus t cubed, and then drag down over here a t and a 1. Okay, so now do this again for doing the subtraction over here, leading that. So now what I'm going to do is we'll actually subtract a minus t to the negative 1. So doing so, that'll yield us with t to the 7 here, then minus t to the power 4 over here, and then a t. Now just subtract all that. So this will cancel, this will bring down a t to the 6, and then now that will actually cancel over here. So this will bring us a minus t cubed, and then that will cancel the t, and then we're just left with a 1. And so this is nice that if we actually now multiply a minus t to the negative square, so it is actually nice that we have a t to the 6 over here, then a minus t cubed, and then a positive 1. Subtract all that, we have a 0 remainder, so therefore this actually divides everything nice and easy. And this is nice that therefore performing that division, this is going to yield us t to the, or rather minus t square, then minus t to the negative square, then minus t to the power 1, and then minus t to the negative 1. So let me just unbox this just to see just so you guys understand like what's going on, what we're doing so far. Okay, but that does not mean that's our final answer yet, because we have still yet to do any sort of integration. Okay, and so what's left is that now going back to what we said that this is originally the integrand we want to solve for. Therefore, that performing all this out and then multiply the 1/2, that means, let me just go into this line over here, that this will yield us minus, and then I can actually just factor out everything minus. So that means this is minus then t square, add this with t negative square divided by 2, minus then t to the power, and then add this with t to the negative 1, and divided by 2. Replace that all back for our substitution for t equals e to the power ix. So then that will yield us with just e to the 2ix plus e to the negative 2ix divided by 2. Add this, or rather, these are minus, so I keep forgetting to disregard. I keep disregarding the minus for some reason. Minus, and then e to the ix plus e to the negative ix divided by 2. And so therefore, just by definition, that we can actually, we know that that's equal to cosine of 2x with the negative, and then subtract cosine of x. And so what's left now is actually to perform the integration that, I'll call this thing capital I, so let me just put that in the beginning over here, capital I. So that means capital I is just equal to the integral from 0 to pi over 2 of negative cosine of 2x minus cosine of x dx, which is just equal to just minus, and then we have 1/2 sine of 2x, and then add this with sine of x. And of course, evaluate this from pi divided by 2 to 0. And this is straightforward to see that if I just plug 0 for sine, then that means everything is going to be 0. And if I plug pi over 2, that means over here sine of pi is just going to be 0, and then sine of pi over 2 is just equal to -1. So therefore, this is just equal to -1, which therefore is the final answer for our trigonometric integral, just like that. Easy. Not a lot of integration going on, but it's mainly the trigonometric techniques and that whole long division of polynomials, just like that. So yeah, that's pretty cool if you ask me.